there's like you can work on variety of things, right? So you can become blockchain core developer. Like say if you work on say Bitcoin's core code, right? Or if you work on so for Bitcoin's core code it would be C++. For uh, Ethereum's core code base would be Golang.
Okay.
But it depends again what you want to achieve. So if you are going to write smart contracts, you can if you want if you are building smart contracts, then you can use Solidity. Um, that's what Ethereum uses for Hyperledger and all these other chains. They have their own languages. So it again depends. It's like there's not one language that everyone uses. It depends on the specific use case, on specifically what you're trying to solve. What I would recommend is if if you are getting started or something like that, it's beneficial to have JavaScript background. I would say like for Ethereum as well. If you are to build a dApp, you need to have you use like Gut3.js, Gut3.js. That's a very famous library that everyone uses. So you need to have, and Solidity is also quite like JavaScript. So um, having a JavaScript background is good. But again, it depends. Which application you are building. There's not one language as such that's used by everyone.
Okay, sir.
Yeah.
Java language is preferable. Okay, sir. Sir, I have one more doubt, sir.
JavaScript. Yeah, JavaScript actually, not Java is. I don't think so. Is used anywhere in blockchain. If you're building a mobile Android app, then you'll use Java, or maybe on the back end, maybe. But not specifically anything related to blockchain, as far as I remember. JavaScript might be good, but yeah, go ahead.
Sir, is there any relation between Bitcoin market and stock market, sir? So normally in stock market, Friday is the end of week, so they don't volatility is more. So due to that reason, they don't want to do the trading. So in the same way, manner or effect on coin market also, it is different, sir.
Um, I don't know. I would say there's some similarities. It's like Bitcoin is more like gold, So you have to. It's a better way to think about Bitcoin is to think about like digital gold. It's basically digital gold. You have scarcity. The supply is limited and stuff like that. So it's more similar to the gold market, but it's similar to the stock market in a sense that you can't. Gold is physical. There are some companies that provide you digital gold, as in like Paytm has this, right? You can buy gold through your app. But usually trading of gold doesn't occur. So Bitcoin is similar to stocks in a way that we have like these exchanges in which you trade your Bitcoin. Um, but I wouldn't say it's like stock market, and it's 24/7. In stock market, you have this 9 to 5 trading, and there's like it's on a holiday or whatever. I don't know. It's not always open, right? But Bitcoin is 24/7. It might be what happens is when Asia wakes up, US is sleeping, right? And usually Asia is the one that pushes Bitcoin's price. So US people are usually sleeping and Bitcoin goes up and down. Yeah, I don't know. It's Bitcoin is completely different, right? So if you try to put it into one bracket and think only from that perspective, you're not going to understand it. It's different. You can use analogies, but it's different than stock or gold or anything. Yeah. Any more questions?
Yeah, hi, Arnav.
Hi.
Yeah, my question is last yesterday or maybe day before yesterday, we have a session, and in that we heard that a hash without a zero is an invalid hash, right? So, is this invalid hash means without a zero hash is invalid in blockchain or everywhere else?
No, so I don't know which session you're talking about. I didn't listen to that, but so Bitcoin is okay. I'll just share my screen for this one. Okay, I think just show you one example. Um, you see this. This is you can see my screen, right?
Yeah.
So you see this hash here.
Yeah.
Yeah, this
Yeah.
hash.
Hmm.
Okay. So this is actually information about Bitcoin's block zero. So the first block that is mined. So it had only one transaction. The difficulty was this. This was the merge root and some other information. So the hash, the Bitcoin protocol has some condition that you need to have certain zeros. The correct hash has to have certain amount of zeros in front of it. It's just for the Bitcoin protocol. It's not for in general. If we look at say so this is the first block. If we look at the block that was mined recently, the latest block, let's look at the hash for that. Um, just show you. Uh, yeah, so this block was mined like 34 minutes ago. Okay, this
Right.
is at right number 6,30,600,000 and so. Um, so it again has some certain amount of zeros in front of it. So it's just some requirement of the Bitcoin protocol. In
No.
general,
My question is, this hash is creating in a blockchain, and these number of zeros are depicting the difficulty levels, right?
yeah.
So, is this if we have, can we have a hash without zero apart from blockchain? I'm not talking about blockchain anymore. I'm talking about general hash. Can it be a valid hash without a zero?
Like in general, hash functions
Yeah.
can be hash, right? So it's just I don't know what I'm not getting where you're confused here, but it's like if this is not the computation, everything happens off chain, right? People are running their computers off chain, and they guess some number, right? So this and they if that number satisfies certain properties, then they submit it. Okay, submit that block with that hash to other people in the network. So that's how it works. So a general hash function can have anything, right? They can you can have starting from 1, 2, 3, A B C D whatever. So yeah,
Hello,
does
hello,
that yeah.
hello, hello.
Hi,
Actually, my
just
question
give me.
is,
Yeah, I can hear you. Go ahead.
what we say that someone who is having the higher computational power, the chances are that
Yeah,
he or she is going to be the miner, right?
yeah.
So, and you also said that owing to this problem or scarcity of resources, China is going to be the pool of miners right now. Hello.
Not
Like,
China.
actually,
There are companies in China.
I'm not complete. I'm not complete. My question is,
Oh, okay.
we
Yeah.
started with the idea of decentralization. Now, the limitation of computation power again forcing us towards centralization. Now, how do we cope up with this issue?
Um. Okay. So this is an interesting question. Um. So there's no such thing, as it's very difficult to build a very decentralized system, right? Like completely decentralized. That's difficult to build. So in specifically for Bitcoin, what happened was I'll just again I'll just share my screen for some time. I had this image. Yeah, so like this is a Bitcoin mining farm, right? It's super big. It's bigger than you can imagine. It's a very big industry right now. It's a multi-billion-dollar industry, and um, this is just a part of the farm, right? It's quite big. And we definitely have some amount of we have centralization in terms of mining power, in terms of computation power, and the reason is that these the economics make sense at scale for Bitcoin mining, right? People when they pool together their resources, they have a higher chance of finding the block or guessing the number. the hash and so on. And in general, like there's a concept of ASICs in Bitcoin, that ASIC mining is what we do. Now people have done have tried to solve this issue in the blockchain space by having ASIC resistant blockchains, in which you don't allow for such large operations. You allow only for GPU mining, in which and GPUs are available with everyone. With ASICs, what happens is there are few companies that are leading in research for those ASIC miners, and those actually then become the major players in the mining ecosystem. With certain coins like Monero, I think Monero does that. We have ASIC resistance, in which you have GPU mining. So anyone with an NVIDIA, GPU can start mining. But the issue with those coins is they are susceptible to 51% attack, and there is some research that has been done on that as well. That's another topic. So yes, in Bitcoin, the mining is where the centralization is. But if you look at like the aggregate of like there are around 19-20 major mining pools, right? So that these are the
One more question, Arnav. Hello, Arnav. Thank you.
just let me finish. So those 19-20 players are the major players, right, in the Bitcoin ecosystem. But we always have this. If you look at their numbers, there are always players that are coming. Still, I would say decentralized, because anyone can do something. Anyone has to open a bank account, they have to, open a new bank. You have to get permission from the government. But if you have to open a mining pool, you just need to, you can just do it very easily. So yeah, it's
Arnav,
decentralized.
Arnav,
Yeah.
do we have any upper limit of number of bitcoins that we have in the system?
Yeah, as I had mentioned that, right? You have, so Bitcoin's monetary supply is fixed. The Bitcoin's monetary supply is fixed. So we know that like for the first 210,000 blocks, the reward for each mining each block was 50 Bitcoins. For the next 210,000 blocks, it was 25. It becomes half after every 210,000 blocks. Now, if and so this goes to, so it goes from 12.5, 6.25, 3.125, and so on. It almost tends to zero. So when I think it's 64-bit number, that the smallest amount of Bitcoin is actually one Satoshi. So which is 10 to the power minus 8 Bitcoin. So when the mining reward after dividing by 2 becomes less than one Satoshi, the mining reward will go to zero, and that will happen in the year 2140. And if you apply solve for this GP, this is basically a GP. You'll get the supply of Bitcoin is actually 21 million. So that's the upper limit of Bitcoin, and of
Actually,
which 21 million, yeah, approximately 17, 18 million or something like that are already in supply. Yeah,
Actually,
yeah,
I just wanted to link this to the inflation that we discussed. When we started with Bitcoin, the initial price of a Bitcoin was of roughly $10,000, and now this is say we are having it around whatever, I don't know what is this,
90.
but the thing is, the price of
This,
Bitcoin is going down.
yeah.
The worth of Bitcoin is going down. So it is in the case of the real currency that we have in the system right now.
So so first of all, the price of Bitcoin is not going down. Initially, price of Bitcoin was like $0.001 in 2000, or it was zero almost in 2009, right? But it the value of it in comparison to US dollar, it fluctuates. So you have to think of it as gold here, right? So the value of gold fluctuates. But what's the inflation of gold, right? If you don't compare inflation with the value with another asset, right? You don't say, okay, inflation is only dependent on how many units are in supply currently and what's the rate of increase of those units. And so for gold, the inflation is very less because gold is very hard to mine, and you can't. Gold is very unreactive, so you can't produce gold as such. Similarly, for Bitcoin, the inflation of Bitcoin, that is the number of new Bitcoins that are coming in supply, that is fixed and that is decreasing with time as well. And the important thing is not that the inflation is the important thing here, which I wanted to say was like in Bitcoin, the inflation, the monetary supply is fixed, right? But in the government system, no one, it's not fixed. Governments can, if they are going to war, they are going to print money, right? Or sometimes the economics are not. If you look, you need to just look at Venezuela or Zimbabwe, right? The how much money printing the government has done there. So the inflation is in regards of that, not price against INR or USD. And Bitcoin's price has gone to 20,000 as well, so it's quite less comparison to that.
Okay, thank you.
Yeah. Yeah, I'll just take. I think we can go for some more time. I think this would be helpful for other people as well who are listening in. So if someone has some more questions, we can go for another 5-10 minutes.
If the time permits, then I can go for one more question as such, or no? May I?
Okay, sure.
Thank you. Now, what we see, if the government has control on the money, so what
Yeah.
we have got our taxes all paid, and everything goes with the system. So it's a
Yeah.
public money that is invested on the public asset. Now, when we go for cryptocurrencies, everything is very specific, very person to person. If this is the case, then how the social upbringing will take place? How the taxes will be funded to the government?
You don't. Yeah, that's. Yeah, so it's like I think the right way to think about crypto in regards of this is it's
That's why I feel the governments are against it. Because initially it can be choice, but afterwards, if it takes place, then everything will be out of control.
so okay. So one thing you need to remember is the governments are competing against each other as well, right? So if like say government of Singapore is in favor of crypto, then people will move to Singapore, or they like crypto people already they don't I know many people who have moved from their main home countries. And usually it's like it's governments are competing themselves. If it was only just one country, one system, it would have been difficult. And in general, it's just code, right? It gives you it's sort of it's against democracy in a way, or like the recent ban that was lifted was because of the fact that arguments presented was the government can't stop people from. We are in a democratic world. You can't stop people from investing in whatever you want. You can't stop people to trade in whatever you want. Um, and government can still use tax system, and the government actually still. So there's company called Chain Analysis. They help governments to track transactions. If someone is not paying taxes or stuff like that, they help governments to do that. Now I know a lot of people who prefer to get paid in Bitcoin or crypto because or privacy coins like Monero, because you don't need to pay taxes and stuff like that. So there's still, I think, yeah, we'll wait and watch, but it's still quite small level. It's just very niche audience that is using it, and it's just an alternative system. And I don't think it will get banned because Japan has now accepted it, and if certain amount of governments start using it, then it's very difficult for one government to ban it. If they do, then people will move from there or find something else, and they'll get left behind. Um, yeah. Yeah, and someone was asking about Python implementation. I don't know Python implementation regarding what. You can look at some, I think, Python packages for Ethereum, maybe. I don't know, but Pythonism, Python packages related to what? Yeah. Any more questions? I'll be happy to answer maybe one more question, and
Yeah,
then
hi
we'll start
Arnav,
with
it's
the
Pankaj
presentation.
here.
Oh, hi, Pankaj.
Yeah, What my question is there, when we do the Bitcoin transaction, okay, so can we trace that with the transaction hash, the coin has transferred to which country or which exchange?
No, you can't. Okay, so you can just look at the blockchain and you can say that this address transfers funds to this address. That's it. That's what on the block. It's on the blockchain. But some exchanges, most of the exchanges, their addresses are known like widely. That this is Binance, like or Coinbase or these famous exchanges. So people can say, okay, this account belongs to this exchange. But if say someone just created a new private key, public private key pair, and just created a new address, it's very difficult. Yeah, it's very difficult to know what who sent it, if it's at which country and stuff like that. You can't predict it. And most of the people who are very privacy conscious, they use Tor or they use. I know they. If you're interested in that, I can guide you through that. I don't think so recommended to say these things on in yeah as such, but there are certain ways you can make it very hard for the government to track or anyone to track your IP or and stuff like that. But I would say Bitcoin is not that private. It's not recommended to if you want to do a private transaction. I won't recommend it. Recommend Monero. That's the one that people use. Um, yeah. Yeah. Any possibility of cryptocurrency bankruptcy? What are the legal course of action? I don't know what this is not. I would say related to the technical aspects or the overall architecture, but bankruptcy as in is like when your money goes to zero, like or you owe a lot of people. So that's not possible as such in crypto. You have if you have if you if you have money cryptocurrency, you have it in your private key. If you don't have it, you don't have it. And in respect to recovering the money, if like say if you it's difficult. So again, that's where the challenge is. If things are not regulated, then you'll see these things happening. That you'll see scams happening. You'll see people running away with other people's funds. Like say someone running a Ponzi scheme and stuff like that. Still happens a lot in the crypto industry. Although I think people have now matured, uh, they understand what's right, what's wrong. But these things do happen, right? Like if someone opens up a company in Virgin Islands or Malta, or a very small country in which the jurisdiction and the legal system isn't that great, and you somehow have this do a Ponzi or something like that, in which you say, okay, if you bring other people to the system, then we'll give you rewards as well, like a MLM or something like that. So that does happen, I would say. But company, if you are interacting with a company in a legislation like India or Singapore, US, I think these things don't happen here because the governments are we have a proper legal system, and that's why we need laws and stuff around this, right? We don't when the India's ban happened, uh, India's crypto ban happened, what eventually started happening was people started trading in cash, and we had a cash crypto economy that developed. And then people who were even willing to pay taxes on their gains and stuff like that, if they are trading on cash, you can't get taxes from them. Instead, if everyone is trading on regulated crypto exchanges for capital gains, you can get taxes. So yeah, that's why we need regulations on crypto. So yeah, any one more question, or I'll just move ahead. Cool. So let's move on to the presentation. So my yeah, can everyone please mute themselves? For this presentation, the goal is to talk about some areas of research and development that are happening in the crypto industry. And just as a side note, I highly recommend everyone to run a Bitcoin test node So you learn so much by just running a testnet node. So for Bitcoin, we have like the core, the main, main Bitcoin network that is running, and in which everyone is mining and stuff like that is happening. But there's also a testnet that runs, which is run by the Bitcoin's community, in which the value of those testnet Bitcoins, they don't exist. They have zero value. They really have zero value. Not like the main Bitcoins. And the developers, people who are building applications, building wallets, building companies, they use testnet. And the size of the testnet node is less. It's, I think, 20 GB or 30 GB or something like that. And main network node is more than 200 GB now. So highly recommend everyone to run testnet Bitcoin node. It's very simple. You can just maybe you'll find a tutorial. If you need any help, just mail me as well. But the things you learn by just running a node, seeing the blockchain, it's very empowering. To run your own node. It feels very empowering. You are just part of the whole system. You have almost the same power as everyone in the system. Although you might not be mining, might be just validating transactions or just looking at the chain, but it's still quite empowering. So for the topics I'll cover in this presentation will be four topics. I'll mostly talk about Lightning Network, which is layer 2 scalability solution on top of Bitcoin. And some of the other topics we'll cover are DeFi, privacy, and scalability. DeFi stands for decentralized finance, and privacy and scalability are again some interesting research topics in the Bitcoin industry. So let's look at the introduction to layer 2, right? Lightning Network and developing on top of layer 2. So right now, if you do a Bitcoin transaction, transactions aren't instant, and micropayments would actually work. So if say you wanted to do a transaction of $1 or 1 cent or something like that, you won't be able to do it. It's like if you are going to pay $1 to do a transaction of 1 cent, that doesn't make sense, right? And the transaction fees, Bitcoin transaction fees, is around $1 or $2, $3. And during the hype, during the hype of 2017, Bitcoin's price had risen to almost $20,000. Um, the price of doing one transaction had gone up to $50, and yeah, the price of doing transactions had gone to $50. Can everyone please mute themselves? Yeah. I can just show the graph of Bitcoin fees as over time. But it's like the block size of Bitcoin is only 1 MB, and there's certain limit of how many transactions can go in that block. And because each transaction takes certain amount of data, and 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 uh, and the price is defined by the market, right? If someone is paying a miner $1 for a transaction and someone is paying $10, then the miner will go ahead with the person who is paying $10, right? He or she will include that transaction in the mining in the block. So this is like the chart of Bitcoin's transaction fee. So you might see, okay, at this point in 2009, it was almost zero. Very less. Then started increasing. Then and this value is in US dollars. So in around 2018 time frame, it went to 53 US dollars. Right now it's around $3, which is quite high, right? If it's low if you want to do a global transaction, if you say want to send money outside, you can send for $3, and the Bitcoin network doesn't charge commission or something like that. Like say if you wanted to send, people have sent like $1 billion or around that in Bitcoin for like $2 or $3, right? Moving $1 billion in a bank for $2 or $3 is not is something which is unimaginable. But in Bitcoin, people have done it. But if say you want to only send $10, you want to buy a cup of coffee for Starbucks maybe, 300, 400 rupees, which is $5 or something. So spending $3 in transaction fees doesn't make sense there. So um, so the Bitcoin transaction fees problem is really big. It's $3 right now, which is quite high. And as Bitcoin gains more popularity, this value is only going to increase. And just looking at the numbers, 1 MB block, we have 1 MB block that gets mined in every 10 minutes or so, and we have like seven. If you look at, like, say, each transaction has 250 bytes, you'll get around 7 transactions per second that Bitcoin network can accommodate. And there are 220 million transactions per year. I think this number would be quite high now, given we have, like, India say UPI or all these things. And yeah, so uh, we have, and this is not enough. So 220 million transactions is for the whole Bitcoin network for the entire year, and this is not enough for a city, and definitely not for the world. And 1 billion transactions per day, if Bitcoin had to do that, then we needed to have a block size of 1.6 gigabytes. So 1.6 gigabytes that would get mined after every 10 minutes. Then we'll be able to do, 1 billion transactions per day. And maybe, yeah, and then that too, that might be, say, I don't know the exact numbers, but um, this would be sufficient to an extent. And okay, so this was if we have 1 billion transactions per day. If we have like 7 billion people in the world doing 2 blockchain transactions per day, let's just say an average. Like, say, if when the economy opens up after coronavirus, I think all of us use Paytm and Zomato and all these things. For me personally, I might do like 20 transactions per day. So on average, if we take 2 blockchain transactions, 2 transactions for 7 billion people, you need 24 gigabyte blocks for 10 minutes, right? And bigger. So why can't we have bigger blocks, right? Why can't we have a Bitcoin network that runs these big 24 gigabyte blocks? The reason is centralization, right? If if we have 24 gigabyte blocks that get mined every 10 minutes, one is like we need everyone would this 24 gigabytes of data needs to be communicated throughout the network, right? And for that we need really fast internet connection, and we need really powerful computers. So what that would mean is, like, I won't be able to run a node on my laptop. Now, right now I can run a node on laptop. It might not be mining node. It might not actually do add blocks to the blockchain, because that for that you need a lot of computation power. But I can in fact just listen to the blockchain. I can listen to what transactions other people are doing, what are the blocks that are getting added. But if the size of the blocks increases to 24 gigabits, then I just won't be able to participate in the network. What we'll have is, we'll have, like, say, two companies that will be running the blockchain, and only they'll be able to see the transactions that are happening in the network. And I think that's what essentially banks are doing already. So that doesn't solve much problem. So basically, bigger blocks means centralization. And so what are the scalability solutions, right? We already have the SQL database model that scales to this scale. And yeah, banks and Facebook and all these social media companies, or all the internet is built using the database model. But that's centralized, right? We have one company that is running those databases, although they might use sharding and other techniques, but it's still centralized. Um, but we don't want that. So what are the scalability solutions? One is sidechain. So basically, I'll walk through the scalability solutions in depth, but here I'm mostly looking at scalability solutions that teams are working on in the Bitcoin space, not in the overall blockchain space. Like, not I'm not talking about the scalability solutions like, say, that teams are working in Ethereum. Just focusing on Bitcoin here. And sidechain is one solution. You can read more about it. It's basically you run a parallel chain in which it's sort of like a permission chain, and you have some validators that are doing the transactions, and you can um, move funds from your main blockchain to the side chain and vice versa. But again, it's not that ideal because the side chain is it's sort of centralized, and you don't know what yeah, it's not recommended you, because side chains you'll have 4 or 5 people who are basically running nodes for that, and they can collude among themselves, um, and stuff like that. So again, it comes back to the centralization problem. um, and then we come to payment channels, right? So payment channels is an interesting topic, and that's what Lightning Network is. In fact, it's a special payment channel to an extent, and payment channels are beneficial when uh, people pay each other many times, right? Like say if we have I have I you go to Starbucks every day, or I go to Starbucks regularly. I open a payment channel with them, and I know that I do transactions with them every day. So it makes sense for me to open a payment channel with them, and then we can do off-chain transactions. And I'm just giving an overview here. We'll just look at how a payment channel works, and stuff like that just about later on. Yeah, so some interesting documentation on Lightning would be reading the LND documentation. So LND, Lightning Network, has various implementations. So there's this company called Lightning Labs, which is backed by Jack Dorsey from Twitter and great VCs and stuff. And you can they have their implementation called LND. There's also C Lightning is another implementation of Lightning Networks that is done by a company called Blockstream. Um, there's also another implementation of Lightning, but the most used one is LND, by the Lightning Labs team. And an interesting book for this would be the Mastering Lightning book, which is open source. You can read it on GitHub. I think it's still developing. People are still working on it. It's not finished yet, but you can check that out. So for payment channels, the main one interesting concept for payment channels is hashed contracts, and hashed specifically hashed time lock contracts, right? And so this forms like the core of the payment channel concept or topic. And the idea is like, say if Alice is this is Alice, this is Bob, this is Charlie, and Alice has a payment channel with Bob, and Bob has a payment channel with Charlie, and Alice wants to buy something from Charlie for 1,000 satoshis, right? And is basically the smallest unit of a Bitcoin. So 100 million Satoshi equals one Bitcoin. So Satoshi is something like, you can say paisa. Like one paisa is the smallest unit of a rupee, and 100 paisa equal to one rupee. But in Bitcoin, we have 100 million Satoshi equal to one rupee. So equal to one Bitcoin. So you don't need to buy one Bitcoin. If people say, some people think, okay, you need to buy one Bitcoin. You can buy 0.00001 Bitcoin. You can divide a Bitcoin. The smallest unit you can buy is one Satoshi, which is equal to 10 to the power minus 8 Bitcoin. So yeah. Now, so let's look at this example. Okay, so we have this scenario: Alice, Bob, and Charlie. Alice wants to pay Charlie, and we have this payment channel. So just keep in mind that we have this concept called payment channel, right? Just don't no need to think about how it's working. Just have it just in mind. And we have Alice that wants to pay Charlie, and we have Bob in between. So how would how would Alice pay Charlie with Bob being the intermediary? Right? So what happens is Charlie creates a random number x, and he hashes that to get h of x. And via a secure non-blockchain channel, Charlie sends h of x to Alice. Maybe through a wallet like a Bitcoin wallet or something. He sends h of x to Alice. Now, Alice uh, what Alice does is Alice sends 1,000 satoshis and h of x to Bob, and the condition is that if Bob gets to know x, only then he'll be able to redeem 1,000 satoshis. Okay, and now what happens is Bob. Um, and just to clarify, the condition is if Bob tells Alice X, only then he'll be able to redeem the 1,000 satoshis. Now in Charlie, what happens is now what Bob does is he sends Charlie 1,000 satoshi and h of x, and he tells Charlie, okay, if you tell me X, and Charlie will be able to get 1,000 satoshi from Bob only if Bob tells Charlie X. Sorry, only if Charlie tells Bob X. So, this might get a bit confusing, but let's understand. So we have this system, right? Alice, Bob, and Charlie, and Alice wants to pay Charlie, but Alice doesn't have the payment channel directly with Charlie. Alice has a payment channel with Bob, and Bob has a payment channel with Charlie. And this is what happened. Charlie created h of x and x, gave Alice h of x. Alice gave 1,000 and h of x to Bob, and 1,000 Satoshi will be recoverable by Bob only if he tells x to Alice. Similarly, Charlie would be able to. Similarly, Bob will be able to recover if Bob gets x. Then only he'll be able to send Charlie 1,000 satoshis. So what essentially ends up happening is Charlie tells Bob X, Bob is able to get uh, tells Charlie X, and Bob then sends Charlie 1,000 satoshi, and then Bob tells say Alice X, and then Alice sends him 1,000 satoshis. So essentially 1,000 satoshis gets transferred from Alice to Charlie, with Bob being the middle. Yeah, so this is something you can think more about it. I think it's a simple concept using hash functions. Um, and this is another illustration of that. Uh, this is how exactly it happens. We have R, H, and similar to that. And essentially everything is, no one is like talking in English and something like that. Everyone is communicating through signatures and sending data through signatures. Yeah, so that's how it works. Okay, and what happens if Charlie or Carol, Charlie refuses to disclose X? So now if Charlie doesn't tell Bob X, right? So here, if Charlie doesn't tell Bob X, then what would happen is Bob won't be able to recover funds from Alice, and the payment channel of Alice and Bob just gets stuck. And if yeah, so and if her channel expires after Alice and Bob's, she might be able to steal funds by redeeming the hash lock. Um, yeah, and so the thing is, we that's why we introduced some time lock in this. So the concept is HTLCs, hash time lock contract, and there's like a time frame till which you can do these transactions. If no one signs and sends these messages to each other within that time frame, then the payment channel, so as to speak, expires between the parties. Yeah. So yeah, that's how it works. You can look at this more. I just wanted to give an idea on how things work. So this essentially, so I'll just talk about the some overview of this more. So we have Lightning Network, right? So what Lightning Network is, it's essentially this HTLC type. It's a payment channel, and what happens is payment channel. The idea behind Lightning Network is, like, say if there are so someone opened the payment channel, and opening of a payment channel is a blockchain transaction. Say there are 100 companies that are providing these payment channel type solutions, right? Like there are 100 bobs in the world that have that are willing to open payment channels with other people. So like say there is a bob in Chandigarh, there's a bob in Delhi, there's a bob in New York, and so on. So now I would connect to my bob in say a company called, say, I don't know, SBI, maybe say SBI, the bank runs a Lightning payment channel. I would send a blockchain transaction and I will open a payment channel with them. And essentially, what you're doing when you're opening a payment channel is you are submitting some funds to that payment channel. You are, say, I submit one Bitcoin to that payment channel, and then you can always withdraw funds from that payment channel. But that funds get locked in that payment channel till you withdraw them. So now, what would happen is I would send, say, one Bitcoin to the SBI payment channel in Chandigarh. And if I have to send, say, funds to someone who is in New York and who has a payment channel open with, say, Wells and Fargo. Yeah, someone has a payment channel open with Goldman Sachs in New York. So, and Goldman Sachs, yeah, can everyone please mute their mic? It's quite disturbing. Um, yeah, so if yeah, so if SBI, if I SBI Chandigarh and New York, Goldman Sachs New York, if they also have a payment channel, right? So we have New York and SBI that have a payment channel, and this is me, and I have a relative that has a payment channel with SBI, and I have a relative in New York that has a payment channel with Goldman Sachs. Then we can do these off-chain transactions. We can send money, and this is not happening on the blockchain. So when I opened a payment channel, that was a blockchain transaction. But when I'm sending these funds using the payment channel, then those are not blockchain transactions. That's just like happening off chain. Although, since we are using signatures, you are signing your message using your private key, your say Bitcoin private key, so that shows that okay, this is you actually that is spending those funds, not a bank or payment channel company can't spend your funds as such. Um, but yeah, so that's how it works. And so this system sort of is again infinitely scalable. So the only limitation is around opening payment channels. So everyone has to open a payment channel with someone. Once they open that payment channel with someone, and if that person is connected to almost every other major payment channel provider, you can send transactions off chain to people using this Lightning network. So that's Lightning network is this the network of these payment channels, essentially the what's called the Lightning network. Um, yeah, and my goal with this is not to go into the real specifics, but just to give an idea of how these things are working, so that you can, if you can look at this more closely and read the Lightning white paper and so on. So yeah, that's Lightning aspect of things. Um, and this lightning work on lightning is happening really fast, and there's a lot of research. Most of the core Bitcoin developers are, I feel there's some interesting things happening in the Bitcoin core protocol as well, that keeps on happening. But many of the research work in Bitcoin specifically is now happening in lightning. So definitely have a look at Lightning, and what Lightning Labs is the company, what they are doing, and try to run a Lightning node. It's going to be really a learning experience, but this is Lightning Labs. So yeah, that's the Lightning aspect of things. Now let's move on to DeFi, which is decentralized finance. Um, Yeah, and for this, I'll just refer this website called DeFi Prime. Yeah, this one. So for DeFi, my plan is to walk you through some interesting projects in DeFi and explain what's happening, what are various research areas, and what various teams are building. So what the whole ecosystem of DeFi actually started because of DAI, this DAI, which I had shown in the previous presentation as well. And DAI was built by the Maker team. So Maker is this project. Um, it's a DAO, 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 a decentralized autonomous organization, and it's quite interesting what the Maker team has built, and it's so Maker system has two coins. One is called Maker coin, and one is DAI. The value of one DAI is always equal to $1, but the value of Maker fluctuates, right? So if we look at Maker, the value of Maker coin is now around $333, and the overall market cap is 335 million. And if you look at, like, say, the DAI value, it's around $1, right? It's almost $1. So the value of this always stays $1. Um, and how they achieve that, that's a very interesting mechanism. I in fact had made a video on my YouTube channel explaining Maker's system. You can look at that a bit more. But what essentially DeFi plans to do is, so the it's like it's hitting a home run, right? The goal is to get rid of banks, and or at least create not get rid of them, maybe create a alternate finance system that competes with these with the already is existing financial system. So in DeFi, we have products in which you can earn interest. You earn interest if you deposit cryptocurrency. And how that works is really interesting. And beyond the scope of this video, definitely, I would say you can. My goal is just to give you an overview on this. So Compound is a very interesting project that most of the DeFi products, they use Compound. You can see there's on the screen flashing, like, say, on USDC there's 0.75 interest, and on some other coins it's this much interest. So the goal here with DeFi is to have these sort of mechanisms in which people actually have they can see a viable alternative to the current financial system. So, like, say, if you are earning money in a stable coin like DAI or USDC or all these stable coins, you don't feel like, okay, I need to deposit this fund in a bank because I'll earn an interest there, right? So the goal here is to have you deposit your funds on one of these DeFi products so that you can earn an interest here as well. And this is all decentralized. How the architecture works, maybe we can answer in a question or so, but yeah, it's beyond the scope of this call. And there's some interesting products in DeFi like this. This is Uniswap, which is a decentralized exchange in which you can exchange Ether. The ETH is basically Ether. You can exchange it using, say, DAI, right? Like, say, um, let's look at DAI stablecoin. So if I say I have one Ether, for one Ether I'm currently getting around 200 to use all these products. You don't even need to use a bank, and you don't even need to use a private key. You don't need to use a exchange, a centralized exchange. And these trades happen in a decentralized manner in which you are holding on to your private key. And this is essentially, Uniswap is a smart contract that is running on the blockchain, on the Ethereum blockchain, and that smart contract actually does these trades. So it's all decentralized. No one has the power to stop your trade. No one has the power to, get themselves a better price, an unfair price. It's all decentralized. It's all run on smart contracts. Even all these Maker, Compound, these are all basically, all these protocols are smart contracts running on Ethereum blockchain. And yeah, so it's everything is decentralized here. And another interesting project which I find is Argent. Argent uses Ethereum smart contracts um, to basically do this to fund recovery. So what essentially you can do is in a smart contract you can add some addresses as your backup addresses, right? Like say if you say if your funds are stored in a smart contract, which you can do, you can send your ether to a smart contract, and that smart contract would be owned by a private key. And say if you lose your private key, right? Then what would you do? You don't have any option. You lose your funds. But using Argent, they have their own smart contract. Even if you lose your private key, say I have five other private keys, and that I have distributed among my friends and family. I would tell, say, my mom who had one key, my sister, or say my friend, three people out of the five people that are selected. I'll tell them, okay, can you send a transaction to the smart contract to transfer my funds from this smart contract to another address that I own? And if they do that, this percentage depends on which protocol you are using, which product you are using. I've seen it to go up to 7% and stuff like that as well. But here it's 2% on Argent. So that's for the DeFi products we have. And in general, you can go to DeFiPrime.com and look at various projects that people are working on. DeFi is mostly on Ethereum. I would say all 100% on Ethereum. But to be honest, people are most of these projects are in fact smart contracts running on the Ethereum blockchain. So if you're interested in DeFi and if you're interested in Ethereum and smart contract development, I would highly recommend to look at what these projects are working on. Look at Compound, look at Maker. Um, yeah, there are a couple of other interesting projects like there's a couple of other interesting DeFi protocols as well. Uniswap, look at Uniswap, which is this decentralized exchange. Um, yeah. Okay, so that's the DeFi part. Um, and in fact, the value, if you look at like DeFi loans, there are now almost $1 billion that are in DeFi, if I remember correctly. So it's definitely this is DeFi is something which has come up in the last year or so. So it's still early days, but the amount of interest and that has been generated in DeFi, it's quite high. And in fact, in India, I would say in Indian blockchain ecosystem isn't that great. I would say compared to say our other technological ecosystems. But India's DeFi ecosystem is quite good. We have there are a couple of companies. We have Madding Network, that is one project working in the DeFi space in India. We have Instad app, which is again a global. These are all companies, global companies that are competing with everyone that are from India. We have Nuo lending uh, is another one that is interesting. Interesting project from India that you can look at. And again, you can see, okay, these are basically just you can lend and borrow cryptocurrency on these platforms. Yeah, you can check it out later maybe. But yeah, interesting stuff happening in the DeFi space. If anyone is interested to work on this, maybe do research work with a company or do an internship or uh, try to get a job, just let me know. I'm connected with most of the founders of these projects and we'll be happy to refer anyone. Um, yeah, so that's the DeFi part. And let's see, the third one is privacy. So in the next part for research and development, we'll talk about privacy, right? So for privacy, as I'd mentioned in my previous call, we had Monero, which is a privacy coin, and Monero, in fact, is built on an algorithm called it's a fork, uses a fork of Cryptonate algorithm, and it's quite technical how and it involves a lot of cryptography on how Monero achieves its privacy. And in Monero, essentially, you can if we really want to do a private transaction, then Monero is the way to go, right? On Monero, you don't see any which person is hello, Dr. Hasirata, yeah. Okay. Hello, is my voice fine now? Hello, is my voice fine?
Yeah, it's clear, Arnav. You can go ahead. Sometimes there is a network problem, I think, with the participants as well as with us sometimes.
Okay, okay, got it. Yeah. Okay, people are listening there. Okay. So we have in Monero we have this concept of ring signatures, uh, which is quite interesting. And yeah, Monero is really if you are into cryptography uh, and you're interested in the privacy aspect of things, I highly recommend Monero. To look at Monero, and there is another one recently which has come out is Beam and Grin. So I had a chance to interview Beam's founder on my YouTube channel as well. So maybe you can check that interview if you're interested. But Beam is these work on a technology called Wimble. Uh, and this Wimble implementation has various advantages. Apart from privacy as well, it reduces the size of the blockchain. Um, which is really beneficial. Like if say you go from your 200 GB size to 20 GB, then that means that more people can join the network, right? So Mimble is quite interesting, and in fact, Beam I think is these are now top cryptocurrencies within top 100 or so market cap. Yeah, top 150 is the market rank of Beam, and Grin is another cryptocurrency, which is for the 151. They are in fact quite near each other, and people are using them. But for privacy, Monero is the leading one. Um, and if you want, this is one article which I read some time back that explained. Ring CT, CoinJoin, and ZK Snacks really well, and for Mimble Bimble as well. Um, oh, okay. Maybe I'll find a new link. For Mimble Limble, as well, there are a couple of interesting links you can look at. So yeah, that's it for the privacy aspect of things. And if you're interested, just let me know. There's in Bitcoin specifically, there's this concept of CoinJoin. So Wasabi wallet is a desktop wallet that's usually does CoinJoin. It's a CoinJoin implementation, and essentially what it does, it mixes transactions, right? So say if it's a mixer, right? So if say 10 people, and it uses an interesting algorithm, but essentially it requires a lot of people to send transactions and then mixes those transactions and sends new, like say if I had one Bitcoin and I wanted to, uh, get, remove my traceability of Bitcoin. Like if I everyone can see the traceability of Bitcoin from from its origination to its current state. But you can use this mixing, the coin join, or what Wasabi Wallet provides, and you can in fact wash your Bitcoins in a way. You can remove the traceability of your Bitcoin. So what eventually would end is that, like say if I had an address in which I had one Bitcoin, I'll maybe get another address in which, or maybe three addresses, or four addresses in which I get say point 0.3, point 0.1, and point 0.6, or point 0.5 and point 0.1, or some combination of these Bitcoins, and it sort of you can't predict that these coins belong to this address or belongs to that person. So but again, this is people are using Wasabi Wallet to wash their bitcoins in a way, but there are certain limitations to it, and it's still, I wouldn't say it's as secure, it's as private as Monero, because Monero provides on-chain privacy, which is really valuable. And for scalability in general, for another research topic is scalability, right? Blockchain scalability. For that, there is sharding. And I'll just explain sharding very briefly. So in sharding, what happens is you are essentially, as most of you are from computer science background, so you might be knowing about database sharding, right? So it's similar to that. There is two types of sharding mostly in blockchain. One is transaction sharding and one is state sharding. So Zilliqa is one project that's a blockchain, that's a sharded blockchain, and essentially what you're doing is you're dividing the blockchain network into various shards. So say you had in total 10,000 nodes. So what you'll have is you divide the network into 10 shards. You'll get say 1,000 nodes in each shard, and each of those shards is going to process transactions in parallel. So if say initially 1,000 transactions were getting processed, now 10,000 transactions would get processed. Um, and so that's what sharding is essentially. You're dividing the network, and the one issue is like, okay, if say you have very few nodes in the network, then sharding can lead to it reduces the security of the network, that it's easier to dominate one chain then. Like if the computation power is divided into 10 parts, then for one particular chain, it's very easy to 51% attack it or do malpractices there. But there are certain design decisions that you can make. Like Zilliqa, what it does is they have this initial sharding of a sharded architecture, and they have another a DS committee that they say, and that sort of set of nodes govern checks in a way that are all the shards working correctly, or maybe there might be a chance of a 51% attack or something like that. So yeah, sharding is an interesting concept, but sharding definitely requires to have a certain amount of nodes. You need to have lots of nodes to ensure that security remains in sharding. And even ETH 2.0, which is basically ETH Ethereum's newer version that's coming out, they are also using sharding. So Zilliqa had sharding from the starting, but Ethereum didn't. They were just doing normal one chain system, but they are also moving to a sharded based chain with the launch of ETH 2.0. So that's basically sharding. And again, it's a very technical. You can look on this more. We moving on to the next topic. It's plasma. Plasma is specifically designed for Ethereum. Plasma is it's basically like Lightning to an extent, but it's all happening on a smart contract. So we have this, say, a plasma chain sort of that is running. It's essentially a smart contract that is deployed on the Ethereum blockchain, and that smart contract to an extent has its own network within that contract. And Matic Network is one project that's from India, and that's a plasma chain. Um, so you can look at that as well. Although recently there has been work on a thing called optimistic rollups. So most of the Ethereum's Plasma team has now shifted to this optimistic rollups. So, but still, Plasma is an active area of research for scalability of Ethereum, and you have to think that achieving scalability is not one there's not one way to achieve scalability. You can achieve scalability from multiple things. You can have layer zero, layer one scalability, like say using sharding. You can have layer two scalability as well, using Lightning Network or various payment channels and stuff like that. And say you get a scalability of 100x from sharding, scalability of 1000x from a Lightning Network. So the overall scalability would be 100,000, right? So you need to have most of the teams are trying for trying to achieve scalability through various ways, not focus on one thing, but have multiple targeting scalability from multiple angles to increase the overall scalability, so as to speak. And I covered about payment channels and Lightning Network that's specific to Bitcoin, and we also had state channels. So state channels is so payment channels is basically is off-chain transaction only for doing payments and stuff. But like say if you have a DApp, you have Ethereum, right? In Ethereum, you're not only sending payments to one from one person to another. You are interacting with smart contracts. You're say maybe using a social media, a DApp, a decentralized social media network. That's essentially a smart contract. For that, you are not only making payment transactions, you are making smart contract calls and doing smart contract transactions. So for that, you need to have state channels, and state channels. There's this company called L4 in Ethereum that was working, but I would this state channel is quite complex because payment channel is quite focused on payments, and the attack vector, the area of attack that you have to think on payment channels is very less. On state channels, that increases quite a lot. Um, but yeah, people are still working on it, although not as much as say Lightning Network. But still, there are teams researching on state channels, so you can look at that. Um, and another scalability approach is having a different consensus algorithm altogether, right? So we have proof of work that is the most used consensus algorithm, but many teams are now Ethereum is shifting to a proof of stake type system, or some teams are exploring other blockchain types, other consensus algorithm. Like there's this recent coin called Sonana. They have a proof of history uh, algorithm that's slightly different. Then there are even DAGs, decentralized acyclic graphs. There's hash graph which uses a different. They don't use a blockchain as such, but they have this DAG, the acyclic graph that is essentially the that's how the new that's how the consensus looks like. And even IOTA is one example of DAG. I can even show you uh, an image of decentralized acyclic graph to give a better example. Yeah, this is how a DAG looks like basically. This is a blockchain, the state line system, and this is a DAG. And in IOTA, I think it was um, for each node had to do one transaction, or for each two nodes you had to do a transaction or something like that. I don't exactly remember. But again, DAG isn't. I wouldn't say it isn't that popular in terms of not many developers working on it, and there are a lot of issues with them. Like IOTA is not. They are popular, but no developer is building on IOTA. Or not. Most people just trade IOTA. They are not using IOTA as such. Um, but yeah, proof of stake, most of the teams are moving towards that. Bitcoin will always be proof of work. Bitcoin has no plans to move to a proof of stake. Bitcoin's community is not thinking of moving towards proof of stake, but for sharding and for various other systems, you need to have a proof of stake system. Um, you have to need to have some slashing conditions in which and stuff like that. For that, you need to have you need to take stake from as as uh, as the collateral in a way. So you, for that, you need to move to a proof of stake system. But yeah, it's not necessarily. Um, and so yeah, that's some areas I would say. So we covered Lightning Network, we covered DeFi, we covered privacy, and we covered scalability approaches. So these are currency or research is taking place, and you can look at some other areas might be wallet development, like some interesting, like I mentioned, Wasabi wallets that working on coin mixing and stuff like that. Um, but in general, wallets is an interesting area as well. Although it's quite crowded. And apart from this, yeah, this covers, I think, most of the research area in blockchain. Apart from this, there's some non-research, more user-focused research, like say improving user experience of blockchains. That's not what mostly researchers do. That's most like engineers and designers work on that. But there's definitely work required there to improve user experience of people interacting with blockchain. It should be quite simple. So there's this concept of blockchain names. So like say if you have to send a transaction to someone, you need to get their address, right? And addresses are not that readable, they are not that human friendly. So we have this concept of there's this company called Unstoppable Domains. So you can buy a domain, like say I have arnavora.crypto. So if I send someone arnavora.crypto, they enter that to the wallet, they'll automatically be able to generate my address from this arnavora.crypto. And that this is more easily shareable, right? Instead of address. So yeah, that's about it. Um, and from apart from this, if you need to follow some people on, most of the crypto communities on Twitter. Uh, Everyone is almost all the companies are there. Most of the Bitcoin core developers and people involved with the mining exchanges. Everyone is on Twitter, and you can join Twitter. Follow. These are some of the interesting people that I found that I follow on Twitter. And this is just one list. I follow like 300, 400 people on Twitter. Um, and yeah, if you are, I highly recommend to check out Mastering Bitcoin book, Programming Blockchain book. These are two good books. These mostly, I think, I'm not sure about Programming Blockchain, but Mastering Bitcoin, you can just, if you can find it on GitHub. Uh, you can buy a physical copy as well. I have a physical copy made myself, but you can just look at the book on GitHub. It's available freely. Um, you can look at various chapters that are available in the book, and and just go through them. So, and it's quite detailed. Yeah, and what people say that blockchain is and crypto are different and some stuff like that. Again, I'll just like to reiterate that most of the in industries, because of the cryptocurrency industry, and blockchain without cryptocurrency is not, it's like veg biryani. It doesn't exist. And it's like, yeah, people do work on hyperledger, supply chain type solutions, or I some healthcare solutions is like one example. But most of them just end up being POCs. They are just proof of concepts that some big organization uses, but not many of them actually get used by real people. And that's what I've seen. Maybe that might change. I'm not sure, but from what I've seen with my time in the industry, you have to work in something meaningful and something that gets you. I highly recommend to stay on the cryptocurrency side of things in a way. Maybe do some research around the topics that I mentioned: scalability, privacy, usability, um, stuff like that. But yeah, you can look at Hyperledger and these enterprise type permission chains, but you'll not find jobs in that much. You won't find actual usage there compared to the other industry. So yeah, that's about it. For one small thing, I just wanted to, if I highly, you can check out MetaMask. This is a Chrome extension, and so this I have like couple of Ether. This is a test net for Ethereum. So Ethereum has couple of networks. So this main Ethereum network is one account, right? I have 17 Ethers here. Go to send, press here, say I do point, I'm sending point one Ether. Can and this is like the wallet. This provides me with this interface: slow, average, fast, stuff like that. So if I do say fast, I just need to confirm, and boom, it's gone. So this transaction has now been sent to the blockchain. It's pending for the confirmation. But if I go to say I send to this account, um, that doesn't the transaction is not confirmed yet. But yeah, so that's how it goes. It's quite simple for people who are like, okay, can you can just test it out. It's just do it on your own. Highly recommend it. So if you want to get some like testnet ether, just go search for Ethereum testnet faucet. So these are testnet coins, so they don't have any value. So what you can do is you can and so some community members they run these faucets, and if you like, say I copy my address. So I just copied my address. If I copy my address here, and they can just send you testnet ether. So they just sent me testnet ether. So you just need to download this MetaMask Chrome extension. Just Google for MetaMask. That's the name, and you can start playing with it. So yeah, that's it from my end. I'll just hold on for some questions if you want.
Hello, sir. May I audible?
Yeah, yeah.
Hello. Actually, there is a challenge that is privacy. But the monoro and all the things they are take care of the privacy. So, which kind of privacy we can consider and we can consider as a research area?
Sorry, Monero, what did you say? I didn't get that.
Actually, Monero and other applications are already work on privacy preservation. So,
Yeah.
how we can again may work in a privacy preservation? Focus on this
Yeah.
point.
Sure. So for privacy, okay, you need to think there's privacy on chain. So there's layer one privacy, right? So Monero is layer one privacy, in which you have privacy on the blockchain layer itself. Now Bitcoin doesn't have privacy on the blockchain layer. Everyone can see, okay, this address sent this much money to this address at which time. For Ethereum as well, you can do that. So if so, an interesting research area would be, say, working on privacy in Bitcoin and Ethereum. So in Ethereum, there's this project called Tornado Cash. You can look at that. Tornado.cash. They were working. They have a smart contract that basically, does privacy in Ethereum. I don't remember the website. But you can look at this. So you need to remember that Monero is quite small, right? Like not many people use Monero. Most people use Bitcoin and Ethereum. So there's definitely value in researching on privacy in Bitcoin and Ethereum. Um, so yeah, Tornado
Exactly
Cash, I
how
would
we
say
can means related to algorithm or
oh,
means in particular which area we can work in a privacy.
yeah, that's what I'm saying. So look at Bitcoin and Ethereum privacy. So have a look at Tornado Cash in Ethereum. Okay, what's their approach? You can. This is again not people use it, but it's not yet. It's still experimental. And if you can, you in Bitcoin, have a look at Wasabi wallet. You just need to look at it. I can't give you like exactly. You need to spend some time yourself, but
Okay.
yeah, it's not, you'll not be working on core privacy, because you can't make changes to the core blockchain after it's out. So you yeah, so maybe you need to work on a wallet, or a smart contract that does this privacy thing. Um, so yeah, I'll recommend to check out for Bitcoin. Have a look at Wasabi wallet. This is Wasabi, and have a look at CoinJoin, how coin joining works, and maybe if you can write an implementation for coin join, or if you can suggest a uh, a better way to achieve privacy than coin join. So it's like you can't go. You have to look at the existing solutions and the existing things that are out there, and then you can uh, try to submit something of your own. That's how you should do it.
Thank you, sir.
Yeah. Oh, I thought so. I'll just type it out. So Wasabi wallet and Tornado. Have a look at these ones. Just writing them on chat. So for Bitcoin and Ethereum respectively. Any more questions? But yeah, if you are in general interested, just reach out to me on email. My email is I'll just type it here, or on LinkedIn. I'm available on LinkedIn. Let's see. Any questions?
Thanks a lot,
Hello.
Arnav, for this meaningful, insightful, and every concept related to crypto integration of blockchain technology. So we are very thankful to you. You took your time and you just enlighten all the participants here, because most of us are trying to do research, and we are trying to begin with all the blockchain aspects. And as you said, without crypto, it will not be complete as well. Yeah, sure.
Yeah.
So thanks a lot.
Yes.
So we hope to see you again for some future such interactions.
Yeah, sure. I'll be happy. Yeah. That's fine.
Thanks a lot. And we also request, because participants will need some content, though I have recorded all your sessions, but I need some content in the form of presentation. If you can share one presentation of yours which you have like delivered today with the participants, so just forward me on email and then I will just share it with the participants.
Okay. In fact, if you want, I can even share on. Yeah. I'll just share it on the chat.
Yeah, you can share here as well, but I think
Yeah,
few
I'll send you.
10 15 participants right now not here, but I'll share it. Yeah, thank you so much, I got this link.
Cool. Yeah, I'll do that.
Yeah, thanks a lot. So thank you so
Okay,
much, and all the best for your future endeavors. And now I hope the next session will be delivered from Singapore.
yeah. Hope so.
Okay.
Yeah. Let's see.
All the best for your journey, for your future. Right.
Yeah, man.
Thank you so much. Thank you, Arnav.
Okay. Thank you, ma'am. Thanks, everyone. Take care.
Thank you, all participants. Thank you so much. So we will end this meeting, and then we'll again meet tomorrow at 10 a.m. for the last day of this online FDP, and we'll continue with the sessions. And meantime, every content will be forwarded to you along with recording, and then we will have a quiz at the end of our course after lunch. Thank you, all of you. See you tomorrow.